Good morning, guys. Okay, today we're going to be going over 2.2, which is solving inequalities using addition or subtraction. A couple things before we get started. Just because Miss Ramsey and I aren't physically in class does not mean that this is going to be much different than what we normally do. You're still going to be taking notes just like any other normal class. You will have a homework assignment over what we go over today in the video. And even though I know that we're not physically there to answer questions, the one nice thing about the video is that you can pause the video and rewind. So if there was something you didn't quite understand, you could listen to it again. If you need more time to jot some of the notes down, you can do that as well. So just take advantage of that and let's get started. So our objectives today are to solve inequalities using addition and subtraction, and we're going to use inequalities to solve real-life problems. So this first example, or this first concept here, is equivalent inequalities, and I'm going to kind of explain what this is first. So an equivalent inequality are inequalities that have the same solutions. Oops. Okay, so real quick, in the examples, I'm going to write something down that may not make a whole lot of sense at first, but after we go over the addition property of inequalities, I'm going to backtrack and explain. So what I'm going to write down is x is minus 4 is less than or equal to 0. And x is less than or equal to positive 4. And I'm going to go ahead and say that these two inequalities are equivalent inequalities. Okay, and like I said, that may not make the most sense right now, but I'm going to go over the first example and then we'll backtrack and talk about that. So now I'm under addition property of inequalities, and example 1 says to solve and graph the inequality. So the first thing that I want to do, and we're going to follow a procedure that's very, very similar to solving equations. So the first thing that I actually want to do is I want to isolate my variable because I'm interested in what the inequality says about x. So I need to add 6 to both sides to get x by itself. So I have x is greater than or equal to negative 10 plus 6 is negative 4. So what I pretty much did, well, what I did do was I applied the addition property of inequalities. And what that basically is saying that I can add, so if by adding the same number to each side of the inequality, and I'm just going to abbreviate, produces an equivalent inequality. Okay, so there's that term equivalent inequality again. So an equivalent inequality basically just means the same inequality. So I'm actually even going to write this out. Decide that this means same inequality. So let's go back to under equivalent inequalities, my first example. So if I were to apply that addition property of inequalities and take this first inequality and add 4 to both sides, I'm going to get x is less than or equal to positive 4. And you'll see that now I have, like it's really easy to see that I have equivalent inequalities. Well, that inequality, the x minus 4 is less than or equal to 0, is still an equivalent inequality to x is less than or equal to 4. All I did was add 4 to both sides, which is a perfectly legal thing to do in math. So go ahead and, oh, actually, nope, this first example wants us to graph, so let's not forget to do that. I almost forgot. So this is kind of going over again what we did yesterday. When we graph, we're interested in that -4 point. And I'm going to go ahead and put a number off here to the right. So one larger and then one smaller than -4. And again, what I'm trying to do is I can probably mentally test the points in my head. So first of all, I'm going to look at -5. Well, is -5 greater than or equal to -4? And I look at that and I say no, because if I move left on the number line, that's less than -4. But -3 is greater than -4. So since this is a greater than or equal to, I'm going to do a closed circle and I'm going to shade to the right. If you need to do those test points, go right ahead and do it. I'm just kind of skipping that step because we covered that yesterday. So go ahead and work on this second one by yourself, and go ahead and pause the video now. Well, not right now, as soon as I'm done talking. Pause the video and then work this out, and then unpause and see what the answer is. Okay, so hopefully this is what you guys got. So the first thing that I want to do is add 3 to both sides. So I have m is less than or equal to 8. And if I graph that, I know that I'm really kind of crunched on space here, but since you guys are watching this on your computers, I think it works. So I have 8. I'm going to test 9 and 7. Well, I'll test them. And I look to the left of my number line and I notice that 7 is less than or equal to 8. And I have a less than or equal to, so I'm going to include 8 in my point and shade left. Oh, something that I didn't point out in the explanation in the first example is that I want to use a closed circle. So I'll just write it for this second part of the example. So I use the addition property of inequalities first. And I also used a closed circle because I know that 8 is included in my solution. And that says because 8 is a solution. Okay, let's move on. So now we have the subtraction property of inequalities. Very, very similar concept. So instead of adding to both sides, since I have y plus a number, I want to subtract on both sides to get y by itself. Particularly in this case, I want to subtract 8 from both sides. So I get y is less than or equal to negative 3. I'll try to write that a little bit bigger. Negative 3. Okay. So the first thing I did was, I'm going to try to be better about writing these notes off to the side. I use the subtraction property of inequality. And it works very similarly to the addition property of inequality. When I subtract 8 from both sides, I am producing equivalent inequalities. So I'm subtracting the same number on, not of, on each side. Very, very similar to equations. So hopefully this process isn't throwing you guys off. So then let's graph the solution. So this is negative 3. And again, I'm going to choose a point to the left and a point to the right. So because this is less than or equal to, I know that my negative 3 is included in my solution. So then let's go ahead and test points. So I'm going to write this out this time since I didn't in the last one. So negative 4, is that less than or equal to negative 3? And that's kind of a question. Well, negative 4 is smaller than negative 3, so yes. This is. So that means that we are going to shade left because that test point worked. So that means that all points to the left are going to work. Okay. So again, I'm going to kind of explain the closed circle. I know that it was a closed circle because of the less than or equal to part. And I tested a point, negative 4, and I shaded left. So B, we'll go through that together. So I want to solve for M, but I noticed that I have a 1.4 plus M, so I have that extra number. So what I want to do is, and I'm going to switch colors, is subtract 1.4 from both sides. Because that is a positive 1.4 in the first problem. So I'm left with M. I'm going to copy my inequality sign, and negative 8 minus 1.4 is negative 9.4. So I'm not a huge fan of inequalities being written with the M on the right-hand side. So since I'm used to seeing my M on the left-hand side, how I rewrite that is I put M there and I switch my inequality sign. So I think now that this is easier to see what direction I'm going to shade. So again, I'm using the subtraction property of inequality. And it may be worth noting here that I want to isolate my variable. Because just like how we're solving equations, it's the same process. It's just we have inequalities except for equal sign. So I isolated my variable by subtracting 1.4 from both sides. I'm trying to explain this in different ways, so if one way seems confusing, then maybe another way isn't as confusing. And I'm still following like the same steps, even though I'm kind of explaining it in different ways. So let's graph this. M is equal, or not equal, M is greater than negative 9.4. So this is negative 9.4. I'll go ahead and graph negative 8. This could be negative 11. Doesn't have to necessarily be 1 point away. So I'm looking for values that are greater than 9.4. So let's test my points again. So first, let's test negative 11. So is negative 11 greater than negative 9.4? That's a question. Now be careful. This is where your properties of integers and negative numbers are going to come in handy, because if we have a negative 11, that's actually a smaller number than negative 9.4. We have more negatives, which means that's a smaller number. So this is no. Let's go ahead and test the other side, but we kind of know already that the other side's going to work. Is negative 8 greater than negative 9.4? And it is. So be careful with our sign here. This is just greater than, so that means that 9.4 is not included in my solution. So I do an open circle and I shade to the right. So I'll write open circle. Because I had a greater than. Simple, just a greater than, no equal to. So remember, open circles are just greater thans and less thans, and closed circles are less than or equal to and greater than or equal to. So let's look at this real world problem real quick. So we have a circuit, and that overloads at 1800 watts of electricity. So it's like, you plug something in and it only takes so much electricity before it freaks out. So you plug in a microwave oven that uses 1100 watts of electricity into the circuit. So the first thing that we want to do is we want to write and solve an inequality that represents how many more watts you can add to the circuit without causing it to overload. So let's kind of think about what this is asking. The first thing that I realize is that we have a variable, we have an unknown, and what that unknown is how many more watts we can add to the circuit before it overloads. So I'm going to let W be the number of watts that can be added to the circuit. Circuit's always one of those words that I just misspell all the time. I spell it with like a C-U-R. I don't even know if I spelled it right there. Anyway, so that's our unknown, and I pulled that from how many more watts can you add? That's how I figured that the number of watts that I can add was my unknown, because that's what it was asking me. And I just let W equal that for watts, but you could have chosen any variable that you want. You don't have to use W. So let's talk about let's kind of break down the problem. So we know for sure that at 800 watts of electricity, the circuit's going to overload. So in my mind, the thing that I'm thinking of is that if I had 1800 watts of electricity in that circuit, it's going to overload. But we don't want that. So immediately I'm thinking that I want something that's going to be less than 1800. Just something. I haven't written that left-hand side of the inequality yet. Because 1800 is when it overloads. So at 1800 it's going to overload. At 1801 it's going to overload. But at 1799 it won't overload. So the watts that are already being used by the microwave oven, and that's going to be there, is 1100. So that's 1100 watts. So what the question is asking me is how many more watts can I add? That add word is a big keyword. So I want to add W to 1100 to figure out how many more watts I could add. Okay, so now what it wants me to do is, I wrote my inequality. So off to the side here, let's say that 1100 plus W, that represents the total number of watts I can have. Well, that I will have. Okay, but that 1800 is the max. Actually, no, it's not the max. It is when it overloads. So this is at 1800 watts. It overloads. So I want it to be less than 1800. So then all I need to do now is solve. So I subtract 1100 from both sides using that subtraction property of inequalities. And I get that W must be less than 700. If W is 700, then I actually overload. So that's why it must be less than 700. Okay, so there actually is a second part to this problem, but I have to move to the next slide because I ran out of space. So we're still on the watt oven problem. So in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading the circuit? Well, remember we said that W can be in the previous slide. We said that W must be less than 700. So what I need to look for are the appliances that are less than 700, and we're talking about appliances that are being plugged in at the same time. So I know immediately that I cannot plug in the hot plate because 1200 is not less than 700. And that slash, I'm just saying that that's not true. So I also know that the toaster, because that's 800, and 800 isn't less than 700, it's larger than 700. So what I'm left with is the clock radio and the blender. And I can actually plug those in at the same time because the combined total of wattage gives me 350 watts. All right, guys, your homework is on Blackboard, and go ahead and get started when you're finished watching this video. It is due tomorrow, like I said at the beginning, so make sure that you're using your time wisely. Ask us any questions that you have tomorrow, and we'll see you then.